Welcome to Seth Vidya Mandir Junior College of Commerce and Science online audio video lecture. Welcome back students. I Miss Alka Chaube explaining new chapter, that is chapter number 5 is Oscillation. So here we have chapter number 5, that is Oscillation. So in this chapter students, first we have to understand some basic concept about oscillation. Before I can start this chapter oscillation, let's move on to some conceptual things. I hope these things you already have studied in school section or in 11th standard also, but here I can give the recall about this concept. So as you know very well students, motion is divided in two parts. As the condition of this oscillation students, here we are dividing motion in two parts, that is non-periodic motion and periodic motion. As you know very well, motions are different type, but here we consider according to oscillation, that is periodic and non-periodic motion. So let us discuss first about periodic motion. The periodic motion is divided into two parts, that is oscillation and non-oscillatory motion. It means oscillatory motion and non-oscillatory motion. And again oscillatory motion, that is oscillation, is divided again two parts, that is simple harmonic motion. It is also known as assumption, that is SHM, and non-simple harmonic motion, that is non-assumption. So here we have the chart about in this chapter. It means in this chapter we are dealing about this chart only. Clear? So let's move on the first concept, that is about the periodic motion. So here we have the periodic motion. Let us understand first what is periodic motion. So periodic motion, a motion in which itself repeat after certain interval of time, is called periodic motion. It means in this periodic motion we are dealing about the motion which repeat itself at a certain interval of time. It means, let us understand this concept with the help of example. If you are consider a pendulum. So as you know very well, pendulum, like when we hang this pendulum with a tight string and there is a bob is present, and when we apply the force on this bob, so what happens students, it repeat itself after interval of time. So here we are talking about the case of oscillation. Here we are talking about, so oscillation is means what? To and fro motion after certain interval of time, fixed certain interval of time. It means the motion repeat itself in a certain period of time is known as here periodic motion. So here you can see students, suppose this pendulum initially is present in the rest condition. When you are applying the force here, then what happens? This motion start here with to and fro motion. It means this bob is showing here to and fro motion. So this bob is initially moved in this condition and after it's moved here. That is, suppose this condition we consider true, 2, and this condition we are consider 4. So to and fro motion is going on. It means we are talking about one oscillation. Then after second oscillation, and then after here we are talking about the third oscillation. It means this oscillation is happen after certain interval of time is called the periodic motion. Let us understand the some other example, like the example is very natural here. Here I consider a sun and the surrounding orbit earth is present. So as you know very well students, after certain interval of time, it means the earth is revolving around a sun. It means the earth is perform here the revolution. It means the earth is perform here the centripetal force or gravitation force. Every force is applying here. The earth is here moving in a circular direction. So here the earth is taking 365 days to complete its rotation. Rotational motion is present here students. Undoubtable. Here we are getting the rotational motion. But here the rotational motion having the certain time period. It means the one rotation. It means the earth, suppose we are talking about this is the main position, and in this position when the earth start from one position to another position, this position, from this position to complete this position, the earth required 365 days to complete. This type of circular motion is known as your periodic motion. Then here students, we have the next condition, that is non-periodic motion. In the non-periodic motion, it means a motion which not repeat itself at a certain period of time. What does it mean? It means, students, we are talking about a motion which is not repeat itself after a certain interval of time. Is called non-periodic motion. Let us understand this concept with the help of example. So here I consider the first example, that is projectile motion. As you know very well, students, the projectile motion, as you seen in your childhood, suppose like we are taking any object and we are throwing that object from the surface of earth. This is, we are consider a vertical surface of earth. From the vertical surface of earth you are throwing any object in upward direction. Then, as you know very well, when you're throwing any object in upward direction, then what happens? After a certain period of time, that object is going in a downward direction. So here the potential motion is present. After potential, the kinetic energy, and after kinetic energy, again it is converted into potential energy. So this motion is not a certain period of time. It means this body is not moving after certain interval of time. Here we are getting a time period is not fixed when this body is moving from this position to this position. So this is about the projectile motion, which is related to the non-periodic motion. Let's see some other example. This example is also very simple or very famous example. Like we are consider any object, and here we are consider a surface. The surface is non-frictional here, and here we are taking any block, and when we are applying force on this block, once we are applying the force on this block, what happens? This body is start to move, and then after certain velocity this body again stop. It means when this body is moved from this position to this position, the motion, the velocity of this body, the velocity of this block is not constant from initial to final position. This type of examples, it's talking about the non-periodic motion. It means the motion which is not repeat itself after certain period of time. So this is all the example of non-periodic motion. In our nature also, students, we have lots of example which is non-periodic motion. In the periodic motion, we can say the fan also the example of periodic motion. But in the non-periodic motion, we have lots of examples. The non-periodic motion, when you are cycling, when you are using any vehicles, this all is example of non-periodic motion. Let's see the next concept, that is about the oscillation. What is oscillation first, and how the oscillation is divided in simple harmonic motion. So here we have the concept of oscillation. So the first we have to understand what is the meaning of oscillation. Oscillation means a motion repeat itself is called oscillatory motion. Yes, student, this is similar to the periodic motion, as you have seen already about it, periodic motion. And here in this chart also, students, you can see the periodic motion is divided into oscillatory motion. Okay. So here this oscillation is nothing but when somebody is asking you what is oscillation, in a very simple way. So you can say a motion repeat itself. It means a motion repeat itself after certain interval of time is called a periodic motion. Or this is also known as oscillation. So here again we are taking the periodic motion example, that is the pendulum here I am taking. So here the string is present and bob is attached to this string. As you know very well here, students, the two force is present when this bob is present in the rest condition. It means the bob is present in the mean position. When the bob is present in the rest condition, we can consider this condition is mean position. Here you can see mean position. It means the bob is present in the rest condition. So when the bob is present in the rest condition, that time the net force effect is zero, students. How? The bob is having the gravitational force, that is force is applying here down, that is mg. Okay. And the string is also moving in, string is also applying the force in upward direction, that is tension. So the net effect of this force is zero at the mean position. It means when the bob is in rest condition. When you are applying force on this bob, what happened? As you know very well, the bob start to oscillate. and the to and fro motion is happen here after certain interval of time. This condition we are considered as an oscillatory motion, and this is also known as oscillation, and this is also considered as a periodic motion here. Here I can take one more example. This example already have done in 11th standard maybe. So here I am taking one more example. The surface is present here. The horizontal surface is present here, and here you can see a spring is connect with this surface with a vertical surface, and there is one block is present. And when you are applying force on it, it means when you are applying the force on this block, then what happens? Because of this spring, because the spring is attached with this block, when you are applying the force on this block, it means when you rotate this block, what happens? When you remove the force, the block is shows here oscillatory motion. It means the block is oscillate here because of this spring. Clear? So this block is also applying here the oscillation motion. In oscillation, students, very important word is also, as you know, this word is very important in oscillation, and you heard this word in a sound chapter, that is because this in sound is like uncountable because of this term, that is vibration. The vibration, technically this word is very similar to oscillation. Yes. Vibration is happen in the case of oscillation when the frequency is high of any object. Yes, students. If we are consider any kind of object, any example where the frequency is high, this type of condition is considered as a vibration, and technically this condition is similar to the oscillation. How? Let us understand this concept with the help of your example. So here I consider the example of like guitar, and here the string is attached to this guitar, and when you apply the vibration of the string, it means when you are applying this force on the string, and when you are applying the large force on the string, what happens? The string is moving in up and downward direction after applying the high frequency on it. It means the spring is moving up and down direction, and this up and down direction of that spring is showing here the vibration, which is technically equal to the oscillation, and this technically equal to the oscillation is happened when the frequency should be high. Yes. In the lower frequency, we are not talking about the vibration technically equal to the oscillation. It is only happens when the frequency value should be large. Clear? And as you know very well, student, the oscillation is also divided in the simple harmonic motion, that is known as SHM. So here the oscillation is divided into simple harmonic motion, because in this whole chapter we are dealing with the simple harmonic motion and non-simple harmonic motion. So before I can start the simple harmonic motion and periodic motion derivation, here I am giving the recall about all these things, and here I am giving the note about and the basic concept about this. So the simple harmonic motion is nothing but the acceleration is directly proportional to displacement. Yes, students. This concept is very important for the derivation, and this concept is very important to understand the simple harmonic motion. In this condition, student, acceleration is directly proportional to the displacement. So here you can see acceleration is directly proportional to displacement. As you got this example in the case of oscillation, so here I am applying this condition. So when we are applying the force on this block, then what happens, students? As you know very well, the body is displaced. When this body is displaced, the displacement and the acceleration is moving along the same direction. Suppose this body is displaced in this condition, so acceleration, suppose the acceleration is happen in this condition, so the displacement is also happen in this condition. When the acceleration is moving in this condition, the displacement is also moving in this condition. It means acceleration is directly proportional to the displacement. So the simple harmonic motion is directly proportional to acceleration and displacement. When we have any examples where acceleration and displacement both are directly proportional, in short, that example is nothing but the simple harmonic motion example. So here, students, we have the introduction about this oscillation chapter. Or in the next chapter, students, we are talking about the derivation about the periodic motion and the simple harmonic motion. So for the next video, students, you have to wait for the next video, and here this oscillation introduction part is over. Let's meet on the next video. Thank you.